Imagine you are on your way to the university. You enter the train and take a seat. You glance out the window and notice a disabled person on a wheelchair who must wait for railway staff to manually install the ramp to enter the train. The staff is so busy that it takes a long time to help manually press up the ramp to get the disabled person on the train, which causes you miss the class time. The manually ramp usually costs a lot of time. There is also a potential safety problem in our daily life. The issue is a large gap between the train entrance and the platform. Wheelchair-bound Pauline David described an average day on City Rail, saying she calls ahead for a ramp, but when she arrives at the station, no staff is ready for her, and it takes about a few minutes to draw the attention of the staff by waving her hand out the door. Moreover, in the news, about 200 children have been hurt in the last year. More than half of the train stations accidents on the 178 station Sydney train network take place at the three busiest stations in the city's central business district. Our solution is the auto ramp system. This is Raven. I will pass on to Yuanbo and No to explain about the technical part of our system.
To solve the problem, our company provides a safe and reliable product, the auto ramp. Our product will be installed at the bottom of the train store to provide a safer way for passengers. To suit different types of trains, we offer two options for our customers. The first design is installed inside the train, which is reliable but takes more space. The second design is installed outside of the train but takes less space. Because most wheelchairs are around 72 centimeters wide, our platform will be designed to be 85 centimeters. The length will be changed according to the different type of trains. The platform is made of steel with a thickness of 4 centimeters, and there will be anti-slip paint on it to ensure the safety. According to our calculations, the average capacity of such platform is about 200 kilograms to 300 kilograms, which is sufficient for passengers to pass through. To ensure the safety of passengers, when the trains arrive at the station, the automatic platform will drop first, and then the passenger door will be opened. This animation shows an example of the use for our product. The next, Norm will show more detail about our product.
Thank you, Yambo. Hi, my name is Noor, and I will go through the technical aspect of our product. Design A is comprised of many primary components, which is driven by a 24-volt DC motor. Two 24-volt DC motor, two telescopic linear actuator, two shafts, two roller wheels, and one plate form the system. Next, Design B, which is a much simpler design, comprised of two DC motor, 4 gears, one cylinder, and one plate. The opening and closing time for both designs is around 5 seconds. The AutoCAD model demonstrates how our primary components in Design A is connected to one another. The telescopic linear actuator is located at the back end of the system and is driven by a 24-volt DC motor. The roller wheels attached to the shaft will assist the motion of the ramp. Here's an animation of how our two design works. The telescopic linear actuator, powered by a 24-volt DC motor, will assist the forward and backward motion of the ramp. The mounted roller wheel will ensure that the ramp motion is smooth and stable. Next, the ramp in System B will fold up into the train door instead of into the train body. The 4 installed gears will assist the folding motion of the ramp. This, as Yuanbo previously stated, will be utilized in a much smaller train doors. Next, I will pass to Junyi for our business and market.
Okay, our market will be focused on New South Wales government railways, and the start point is Sydney. Unfortunately, till today, Australia still uses manual plate and requires the help of staff. Even the up-to-date train called Marion also doesn't have this feature. However, in Singapore, they already have similar design, but only on some bus. But sadly, it's only manually controlled by the driver. To compare with the manual plate, although the manual one is cheap and simple, it takes a long time to call the staff and set the plate during rush hour, and the service may be unavailable for stations in suburbs and at night. In comparison, our auto ramp will be set quickly before the door opens. So in every station and anytime, anyone can have a safer experience, get on or off the train without the help of staff. We actually have a large target market already. There are around 1.9 thousand carriages and 176 stations in Sydney, and more than 3 million passengers every year. Just imagine how busy the stuff is if only 3.6% of the Australian people need a wheelchair. Furthermore, we can also be a part of the government program since New South Wales government has signed $2.3 billion for accessibility service. Now it's time for business model. The revenue will come from New South Wales government, Sydney train companies, and we can get some sponsorship through welfare institutions and disability union. Before the product is sold, we have some pre-costs for designing, testing, and advertisement. Then we will have production costs, installation, daily maintenance, and problem fixing.
Looking through the existing designs and products in the market, we can find three common types of barrier-free solutions with correlative prices. The graph on the left shows a summary of the price range of each product and the average market price, including the lower and upper limits. Since we are sticking to design A, the table on the right displays the cost of the main components in our design, and each piece can be tracked through hyperlinks on this page. By doing the comparison and contrast, our design can be more affordable and has a huge advantage in price. The primary objective of our design is safety. The ramp system must include a safety edge and mat. The surface should be continuous and flat without obstructions and can withstand a load of 300 kilograms. The second most important thing is economy, because we want to benefit all people by providing an affordable price. Next, we want our product to be durable, so we will perform running tests of extending and retracting 10,000 times continually, and add one layer of wear-resistant mat on the top of the plate. Our design will have a bright future and can be improved using lighter and stronger materials such as carbon fiber and polyamide through 3D printing. And the most important thing is that the product of our company benefits all people, including the disabled community, and helps create an equal and harmonious society. Our company started the project a few weeks ago, and we perfect and finalize our design in about half a year. We then assign 1 year for prototypes and tests, and at the beginning of the year 2025, we plan to manufacture and install our design with the NIF, which is a fleet to operate the NSW TrainLink electric intercity services in New South Wales. And hopefully, our products will be ready in the year 2026.
For the ethical and social concern part, it can be concluded into three benefits. First is increased national sense of belonging. When younger citizens see the state's efforts in transportation for the disabled and the elderly, they feel comfortable in their retirement. They will have a stronger sense of belonging and identity to their country, so they will work harder to return to the country and society. The second and third points are creating a loving and harmonious social atmosphere and improving the public sense of morality, social responsibility, and the overall quality of citizens. When citizens of a country see the various efforts made by the country for the safety of people with disabilities and the young children, this behavior will radiate to the entire social state system. Everyone will be affected, and they will be more willing to help each other. Society will become better, and the overall quality of people will become higher. For the risk part, it can be divided into two parts. First is the safety issue, which has already been discussed in the section above. The second part is the investment concern. Our products need to be related to the local transportation. Just talking about the Sydney Railway Department, it has many kinds of trains, so each kind of train needs to be designed with an auto ramp, which will increase the cost and workload. It would be a great expense to research different modules and design unique auto ramp. Secondly, we should expand the scope of the investors, including the Australian government and major commercial companies, to avoid falling into the embarrassing situation of being rejected by one company and unable to continue the research. That's all from us. Thank you.